So in this video, we're going to look at how to complete the square and factorizing equations. First thing we're going to look at is what's called factorizing. So factorizing is when we get a quadratic equation in factored form to find the roots. So that is when we take something like this and factor it into something like that. Okay. We like factorized form because it gives us the roots. So this tells us where our quadratic crosses the x-axis. In the case for this one, it touches it only once. It's great for easy, I don't want to say easy, it's great for simple problems, but as they start to get complex, factorizing gets a little harder and it gets to a point where it might not even be possible. So we have to use other methods. But before we get to those other methods, let's take a look at some examples here. So I will do A for both of these, and then we can do D in class. So starting with x squared plus 3x minus 10 equals 0. Okay. There are a couple different ways you can do this. You can always go through the factoring process, looking at your factors of C. Do they add up to B? You can also use your calculator. So I will look at this one. I recognize as factors, so this is x plus 5 and x minus 2. Okay. And then that's still set equal to 0. So the zero product property says that either this term or this term has to be 0. So then my x is equal to negative 5 or x is equal to 2. So those are my two solutions. Now, if you would have plugged it into your calculator, you would have gotten x1 as 2 and x2 as negative 5. So that's one way. Now we look at a little more complex problem. Now we have a rational equation. We have a variable in the denominator. So what you have to do is you have to factor both the numerator and the denominator. So I have 3x squared plus x minus 10. And then the denominator, I'm going to go ahead and factor this x minus 6, x minus 1. Okay. And then I'm going to factor the numerator. So this ends up being x minus 6, x plus 5, x minus 6, x minus 1. So when we're dealing with rational equations or variables in the denominator, we're going to run across situations where the variable can't be a certain number. So for this one, we have to look we're looking for values of x that make 0 in the denominator. So x cannot equal 6 and x cannot equal 1. So now we're going to solve. So those cancel out. So then we're left with x plus 5 over x minus 1 equal to 0. You're going to multiply by x minus 1. So you're going to get x equal to negative 5. So negative 5 is not 6 or 1. So therefore, that is the solution for A. Like I said, we'll do, I encourage you to try D in your notes, but we will talk about those in more detail in class. So this is, vertex form is one of those other forms I talked about. We're used to vertex form seeing it like that, the H and K form. Okay. Vertex form is where you force a quadratic to be a perfect square. It's useful because if we have to solve for x, say whether we're just solving for it in general, or say we are trying to find the inverse function to where we have to swap the variables, it's much easier to do it from vertex form than it is from factored form or standard form. It also gives us the vertex directly with h comma k being the vertex and x equal to h being the axis of symmetry. So I will show you how to do this one, and then in class I'll show you how to do the calculator. So completing the square, you have to get a equal to 1 first. So I'm going to start with 2x squared minus 12x plus 3. Since it's not equal to 0, I can't divide by 2 to get rid of it, so I have to factor it out. So I'm going to end up with x squared minus 6x plus 3 halves. So that's where I start. So that's step 1 and step 2. Next, we group stuff together. So my 2 is still on the outside. Then I'm going to group x squared minus 6x. I'm going to add, and I'm going to leave a blank, close my group. What I add to the equation, I also have to take away from it because I don't want to change the equation. So I subtract the same blank, and then we add our 3 halves. And then we close our group. Now we have to figure out what goes in that blank. Well, what goes in that blank is step 4 and step 5. So it's b over 2 squared. So I'm going to take negative 6 and divide it by 2 and then square it. So I'm going to get 9. So the 9 goes in here and there. So step 5, the last one, is just to simplify. So what we do is we take this group here, and this is going to become our perfect square. So we're going to have x minus 3 squared. Now some notes on this. This term here is always going to be b over 2. And bring the sign with you. So it's always going to be x and then whatever the sign that you get. If it's positive, it's going to be x plus. If it's negative, it's going to be x minus. So that's that step. So completing the square, you group you get a equal to 1. So that's this step here. Then you create the perfect square. So that's what we're doing here in the yellow. And outside is where we're making sure we don't change the problem. So what we add, we subtract. And now we're simplifying steps. So let me get a different pen up here. So the 2 is still there. And then we have minus 9 plus 3/2. Now, at this point, you can combine these and then distribute the 2, or you can distribute the 2 and then combine, whichever happens to be easier. So in this case, I think distributing the 2 is going to be easier, and then we can combine. So we're going to end up with 2x minus 3 squared minus 18 plus 3. So this becomes 2x minus 3 squared minus 15. And that is our function in, so this is vertex form. And if you plug our equation into your calculator, so a is 2, b is negative 12, and c is 3, you get x1 and x2 as irrational decimals. You keep going, you get a is 2, which we did, h is 3, which we did, and k is negative 15, which we did. So there you go. Now that we learned how to put them in vertex form, now we need to solve them, though. Okay? So solving them, so again, if we look at C, so we get A this time is 1, B is negative 2, C is negative 35. So C in vertex form is x minus 1 squared minus 36 equal to 0. What it means by solving is you're going to solve it from here. And this you'll see why why vertex form is useful to us having only one instance of x. So I'm going to add my 36 over to the other side. Then I'm going to take the square root of both sides. So I'm going to end up with x minus 1 going plus or minus 6. And then I get x equals 1 plus or minus 6. So my solutions are 7 and negative 5, which you can check with the calculator. Now that particular one was a perfect square, so it worked out nice. Sometimes it won't, and then it's best to leave it in the British call surd form, or with the radical symbol in it. When you use your calculator to solve, if you happen to get that your x1 and x2 are really weird decimals, keep going till you get to the vertex form part of it and solve it longhand, because it's going to look a lot nicer in surd form than it is going to be with a irrational number. So let's look at C. So again, we plug in a equal to 1, b is 8, c is negative 1. And if you see on your calculator, if you're doing this with me, that you get x1 and x2 are irrational numbers. But we go on down and we get that vertex form is x plus 4 squared minus 17, and that's all equal to 0. So this is where we can tell our irrational numbers come from, because 17 is prime. So we're going to end up with x plus 4 squared equals 17. So I just moved 17 over to the right. Take the square root of both sides. So I've got x plus 4 equals plus or minus square root of 17. And then I move the 4. So x equals negative 4 plus or minus square root of 17. Now that looks a lot better than an irrational decimal. So you will have to go back and forth deciding what is a better, more accurate representation of your information if the question doesn't specifically want you to do something. So it goes back to our sifter method and always returning to the inquire step and making sure that you answered whatever the question was that was being asked. So in this video, we looked at factorizing and completing the square. Please bring any questions you have to class.